In this video, we're going to cover information to understand the basics of statistics in research. There are two broad categories of statistics used in research, and most often both are done together, and they're both necessary to assess the results of a study. They are descriptive statistics, which describe data without trying to generalize beyond the sample, and inferential statistics, which assess the likelihood that observed results can be generalized back to the population of interest. Let's talk about descriptive statistics in more detail. These are used to describe and summarize a study sample characteristics and their relationships. They usually involve a measure of central tendency, or the central point around which some data tend to cluster, and a measure of variability, or how far away from that central point all the data lie, for each characteristic studied. Measures of central tendency are the summary statistics that represent averages or scores that are representative of the center of a distribution and include the mean, which is computed by summing the values of all observations and dividing it by the number of observations, or the arithmetic average. The median, which is the point in a ranked distribution of scores where 50% of the values fall above and 50% fall below. And finally, the mode, which is the most commonly occurring value in the dataset. So why are there so many measures of central tendency? How do you know which one to use? Well, really, it depends on what makes sense for the report based on the data you collected and the level of measurement associated with that data. The mode can be used with nominal, ordinal, or ratio level data. The median is used with ordinal or interval level data, and the mean can only be used with interval or ratio level data. But remember, we aren't just interested in the middle, so we include measures of variability. Think about it. If everybody had the same characteristics, we wouldn't need to describe them. So variability statistics include the range, which is a measure of dispersion equal to the difference between the largest and the smallest scores. But somewhat erroneously, most people actually report the highest and the lowest scores in the data set, and it really should be a single measure as a range, not something with a dash in between. And then the other measure is standard deviation, which is a calculated value that you use a formula to get in order to show the variability around the mean. You aren't required to know the formula for this course. A frequency distribution can be used to describe the sample's characteristics. It represents a complete summary of the frequencies of the values or the categories, depending on how your data is organized, and a measurement is then made on the group. This distribution either tells you how many people or what proportion of the group was found to have each of those values, or each range of values. A frequency distribution can be presented in a number of different ways. Most often, it's a bar chart for nominal or ordinal level data, or a histogram for an interval or ratio level data. Distributions of data come in many different shapes. Let's talk about a few of them. The normal distribution, or sometimes called the Gaussian distribution, and better known to most people as the bell curve, is a frequency distribution that is continuous and symmetrical, where both tails extend into infinity. You'll also find that the mean, median, and mode are all identical in this type of distribution. Its overall shape is completely determined by the mean and the standard deviation, so whether it's flat or whether it's peaked. A skewed distribution is an asymmetrical frequency distribution where the mean, median, and mode will occur at different points in the distribution. If the longer tail extends towards the lower values, then we call it negatively skewed. And if the longer tail extends towards the higher values, then we call it positively skewed. Finally, we can use box and whisker plots, or most commonly called box plots, which are a standardized way of displaying distributions of data. The midpoint of the distribution, or the median, as we learned earlier, is represented by a horizontal line. The values above and below the midpoint are then divided into quartiles by horizontal lines, which will form the bounds of the box. And that's basically the quartiles nearest to the midpoint, which are the 25th and the 75th percentile. Let's take a step back. What's a percentile? Percentiles are a set of divisions that produce exactly 100 equal parts in a series of continuous values. They can be commonly interpreted as someone in the 90th percentile having a greater value than over 90% of the people in that series. Back to our box plot. Finally, values beyond the box are represented by vertical lines, or the whiskers, and these extend to the first data points inside the ranges defined by the 75th or 25th percentiles, plus or minus, respectively, the 1.5 times the interquartile range, or the difference between the 25th and the 75th percentiles. Looking at a box plot, you can quickly look at the distribution of scores and understand the spacing between the different parts of the box, which indicate the degree of dispersion or spread from the central tendency, and the skewness in the data, and you can show outliers. Box plots are particularly useful for comparing distributions between several groups or sets of data to examine trends over time between the groups very easily. In class, we'll make a box plot together that will help solidify this information and why it's useful.